In this video, we're going to have this discussion of integration by substitution. How can you be able to work out integral of x into 2x minus 3 raised to power 4? How can you be able to work out x square root of 1 minus x squared dx? And finally, how are you going to work out this with 0 all the way to 1? So I'll show you this, but let us begin from here. When we're talking of substitution, we can say let 2x minus 3 be equal to u. We are substituting this part with u. So which will mean that u is equals to 2x minus 3. Then we are going to find we are going to differentiate this because u is a function of x. U is a function of x. We are going to differentiate both sides. So we are going to say differentiating this, we are going to get du is equals to 2 dx, like that, because if you differentiate 3 is a constant, it becomes what? It becomes 0. So with this expression that we have here, we can be able to say, with this we can be able to say du, okay, we can be able to, with this expression we can say 2 dx is equals to du. Then dx is going to be 1 over 2 du, meaning that anywhere we are going to have dx, we can replace that with 1 over 2 du. And we had also said that this expression that we have at this point here, this expression that we have here, is the expression for u with x. Then from here we can be able to make x the subject and say 2x minus 3 is equals to u. Then it means that 2x is equal to 3, rather it's u plus 3 divide by 2, then x is equivalent to what? X is equivalent to what? X, this x that we have is equivalent to what? Is equivalent to u plus 3 over 2. I want you to look at this to give you a life depend on this. This expression is very important. Also, this expression that we have here is very important. So we call this dot and this double dot. Okay. So at that point of time, what I want you to do is substitute where you have x, you're going to substitute u. And where we have dx, we are going to substitute du. So this integral that we were having here, which is x into 2x minus 3 power 4 dx, can be written as, anywhere we have x, we are going to write this. So it will be integral of u plus 3 over 2. But this part is basically u. Alright? So this is going to be times u power 4. And then we are having dx. We're having this dx. But dx can be replaced with what? 1 over 2 du. Okay? So we are having this constant. Let me just put this. We have this constant and this constant. So this is going to translate to, this is going to translate to u plus 3 u power 4 divided by 1 over 2 times 1 over 2 is going to be 1 over 4. Then we have du at that point. So with this, because this is a constant, we can be able to take it outside the integral. So we shall have 1 over 4 integral of, if we multiply this to this, we're going to have u power 5. If you multiply u power 4 times u, I'm opening the brackets here. If you multiply u power 4 times u, you're going to have u power 5. U power 4 times 3, we are going to have plus 3 u power 4. And then we're going to integrate this term by term in the normal, using the normal method of integration. So this is going to translate to 1 over 4, of course. And integrating this, we're going to have what? We are going to have plus 1. So we shall have, let me just put a bracket here. And this is going to be u power 6 over 6 plus this plus 1 becomes u power 4 plus 1 u power 5. So it will be 3 over 5 u power 5 everything. Then we have plus c. Normally we include a constant. So basically this expression that we are having here is going to be what? This time this is going to be 1 over 24 u power 6 plus this, and this is going to be 3 over 20 u power 5, then plus c, like that. Now, we were not supposed to leave our answer in terms of u, because we know what u was. U was what? This part that we are having here, right? So meaning our final answer is going to be equals to 1 over 24, checking whether I'm right in the right place, power 24, and this is u is 2x, so it will be 2x minus 3 raised to power 6 plus 3 over 20 over 2x minus 3 raised to power 5, then plus c as the final answer of this particular question using u substitution. And also this one that we are having here, of course, this integral can be written as x into 1 minus x squared raised to power 1 over 2 with respect to x. So whatever that we are having inside the brackets here, the one that we are going to let to be our u. So we can say let u be equals to 1 minus x squared. Then that will mean that du equals to, differentiating this, we get du. Differentiating this, we are going to get what? 0, because the constant. Differentiating this, we're going to get negative 2x dx. Okay? So which will mean that from here, you can see we are having x and dx. So x dx can be written as x dx is the same as minus 1 over 2 du. I've just divided only by negative 2 both sides, so that I'm going to remain with x dx, which I'm going to replace with negative 1 over 2 du. So this expression that we have at this point, we can be able to say it can be written as 1 minus x squared raised to power 1 over 2 x dx. Yeah, you see now I have x dx, but x dx I'm going to replace it with this part here, and 1 minus x squared I'm going to replace it with u. Okay, yes, u. Okay, yeah, u. I'm going to replace it with u. Then this is going to be integral of u raised to power 1 over 2, u raised to power 1 over 2, and then times negative 1 over 2 du. So I can be able to take this out of the integral. Yes, I'll have minus 1 over 2 integral over u raised to power 1 over 2 du. Okay, so if I integrate this, what do I get? I'm going to increase the power by 1 and then divide whatever I'm going to get. So this one is going to become minus 1 over 2 times, if I integrate this part, I'm going to have u raised to power 3 over 2 divide 1 divided by this answer that I'm getting, so it will be 2 over 3 here, then plus c. So integrating this part, I'm getting this part, then I'll say plus c. So which will mean that our final answer will be minus 1 over 3, because this and this will cancel out, shall have u 3 over 2, then plus c. The final answer is with the value of x, but we know x was, u was 1 minus x squared, so we can be able to replace it here, and that will be minus 1 over 3 into bracket 1 minus x squared raised to power 3 over 2 plus c. And this can also be written as, we can be able to write this expression as, from this part is 4 here, can be written as 1 over, okay, we can be able to simplify this as 3 negative root of 1 minus x squared, x cubed rather, x cubed. We can be able to leave our answer at this point, so that we can be able to move to the next bit here. How can you be able to integrate this? So the first thing that we're going to do here is to say let u be equals to 3x raised to power 3 plus 5. That is the value of u, and then it means that du is equals to 3x squared dx, right? In this expression that we have here, there is x squared and there is dx. So meaning, if I'm having this expression, let me just write it. I'll write with the square root, I can say this is x cubed plus 5 raised to power 1 over 2 x squared dx. So anytime I'm going to have x squared dx, I'm going to replace that with this section here. But this section that I'm talking about, after divide by 3, then we shall have x squared dx is the same as 1 over 3 du. So this part that we are having here can be replaced with 1 over 3 du, this part here. And whatever that is inside this bracket here can be replaced with what? Can be replaced with u, because we are saying u equals to x cubed plus 5. Now, our integral with the correct substitution is going to be what? Our integral with the correct substitution is going to be what? Is going to be this part is basically u raised to 1 over 2, and this part here is basically 1 over 3 du. But the limits, I cannot use the limits the way they are, because these limits that we have in here, the limits are for x. These limits are values of x, but we are substituting values of u here. So which means that for the first part, we need to find what this limit is, and for the second part, what this limit is. So let's find the lower limit. Let's say lower u limit. That is going to be, we're going to use the value of x here, and that is u is equals to 0 raised to power 3 plus 5, and that is going to translate to 5. So this limit here is going to be 5. The second limit that we have is the upper limit. And the upper limit, we're going to use this one that we have here. So it's going to be u, the upper limit is going to be 1 cubed plus 5. This is going to be 6. So here we shall have also 6. Now we're going to perform the normal integration of this. And of course, this is going to translate to, we're not going to include a constant here because we have the limits and the constants are going to cancel out. And basically we shall have u raised to power 3 over 2. Yeah. And this is going to be divide by this power that we have. So 1 over 3 divided by 3 over 2 is going to give us 2 over 9. Then our limit of integration will be 5 and 6. So substituting here, let me just look for some more place at this point here. So meaning that when we substitute this, we're going to have 2 over 9 into 6 raised to power 3 over 2 minus 2 over 9 into 5 raised to power 3 over 2. So if we work out this, we are going to get our answer. Just put this straight in the calculator. Answer correct to just become 0.7815. 0.7815. Okay, the next part that we need to focus on, once you've differentiated, once you've integrated this part to get this one, now the next part that we're going to focus here, once you have substituted this to be the value of u and x squared dx, of course x squared dx is going to be obtained from here. You have du equals to 3x squared dx. For you to have x squared dx, we're going to divide by 1 over 3 both sides. So we shall have x squared dx equals to 1 over 3 du. So any point we are going to have this variable here, x squared dx, we are going to replace that with what? 1 over 3 du. So which means when we are going to have this expression that we are having here in terms of u only, we are not going to write the limits that we were having here. Remember, the limits was 0 and the other limits were what? Was 1, and this limit was what? 0. So in order to get the lower limit with u now, you are going to replace 0 in the expression for u. In this expression, we are going to substitute 0 here. So it will be u equals to 0 plus 5. Therefore, the lower limit for this is going to be 5. And for us to find the upper limit, this is the lower limit, of course we have found it. For us to find the upper limit, we are going to use 1 here. So we shall substitute 1 in this part, so it will be u equals to 1 cubed plus 5, and that is going to translate 1 cubed plus 5 is going to be our 6 here. So that we are going to have our limit from 5 to 6 for this one. Then we are going to integrate this. So to integrate this, we're going to increase the power by what? By 1. So to be 1 over 2 plus 1 to be 3 over 2. Then 3 over 2 divided by 1 over 3. Because this is a constant, it can be written in front here. Because if you are having integral of u raised to power 1 over 2, we shall have 1 over 3 there with respect to the u there. So this is 5 and this is 6. Integrating this, we're going to get u raised to power 3 over 2 over what? Over the constant. But this is 1 over 3. So you'll be having 1 over 3 and you'll be having 3 over 2 here. So if you divide these two, that's why we are getting the 2 over 9 from. Okay? So it will be 2 over 9 u raised to power 3 over 2. Then we substitute the limit, and our final answer is going to be equivalent to 0.78815.